Hello and welcome everybody to your weekly dose of APES 2020. I realize I keep coming up with new titles every time you join. So today's title is APES 2020. And today we are going to be working on FRQ for the year of 2007, and it's going to be question number 3. So hopefully you guys are ready to go, and we can do an answer key video on this. So without further ado, let's do a cool effect. And we are going to start with this material. So the first thing I want to do is read it to you. In the mid-1970s, Sherwood Rowland and Mario Molina predicted a thinning of the stratospheric ozone layer over Antarctica. This seems pretty accurate. We are talking about air pollution after all. The thinning was confirmed in the late 20th century and has continued into the 21st century. All right, so please remember, guys, that we are talking about
stratospheric ozone here. That is the protective layer of ozone. That is the ozone that is very important to us. When we talk about ground level ozone, ozone that has occurred due to photochemical smog, that is the ozone that is dangerous to us. We do not like that ozone, nor do we want that ozone. So, without further ado, let's get this party started. Let's start off right with A. I'm going to put some helpful notes down for you guys. That really doesn't look like an A. There we go. Kind of looks like an A. Identify the class of chemical compound that is primarily responsible for the thinning of stratospheric ozone, and describe two major uses for which these chemicals were originally manufactured. Okay, so if we're talking about the types of chemicals that are used to create, used to eat away or to destroy stratospheric ozone, we're talking about the two major chemicals that fall into the class of chlorofluorocarbons, CFCs, which are chlorofluorocarbons, excuse me, chlorofluorocarbons, as well as hydrocarbons, or halocarbons. Okay, so halocarbons are when we combine a halogen with a carbon, and the CFC has chlorine, fluorine combined with carbon. Halocarbons are used as fire retardants in fire extinguishers. We use them in pesticides. So let's see, fire extinguishers, and we use them in pesticides. Okay. Chlorofluorocarbons are used, it's a horrible arrow, are used in aerosols. Okay, anything that is a spray can. Boy, I wish I could be like one of those cool teachers and do like a spray can for you, right? Hey, look at that. This is like a professional video, guys. This is awesome. It's also used as a cleaner. Here's my little, that's supposed to be a towel, just in case you guys didn't know. I realize you can't see that either, but it says towel. Continuing to move on, both of these can be used as solvents, and those are chemicals to break down other chemicals, which are also termed as cleaners. Okay, cleaners. Yeah, those are the two major ones, right? CFCs and halocarbons. Very important, very important. Okay, we just officially answered that question, and for answering that question was worth 3 points per the original AP exam. So we are good. We just did that. All right, let's move on. I'm just gonna fold this piece of paper. Let's move on to B. All right, so B, describe how the chemical compounds that you identified in part A, so we've identified the CFCs and we've identified halocarbons. So we're going to describe how those two chemicals destroy stratospheric ozone molecules. You may include chemical equations as part of your answer. Okay, what we know is stratospheric ozone is O3. And for all you chemistry fans out there, ozone is bonded in the bent molecular shape. It is double bonded between one of the two O's and single bonded to the other. This double bond resonates between the two bonds, so it's constantly jumping back and forth. Overall, we do have a dipole molecule that brings an overall negative charge here. The electrons are spending more time on the double bonded side, and that leaves us with a delta positive on the single bonded O side. All right, let's see. So now we want to describe how the chemicals, these guys, eat away or destroy the stratospheric ozone. All right, so remember, CFCs are broken down by UV radiation, okay? Now, when we break the CFC down by UV radiation, when we break the chlorofluorocarbons down, when the sunlight hits it, the chlorofluorocarbon, CCl3F, right? Chlorofluorocarbon breaks down when sunlight hits it. And it breaks down into chlorine. It breaks apart a chlorine and still a chlorofluorocarbon. Oh, sorry, but with one less, that's a 2, with one less chlorine, CCl2F. There we go. So now we have this lone chlorine just floating around. So the chlorine is very, very electronegative. In fact, more electronegative than oxygen. For that reason, when this chlorine sees O3, his eyes are like, whoa, he's like really, really big-eyed, right? And he's really happy because he just saw that O3, all right? So now what the chlorine will do, it will take the ozone and it will break one of these oxygens apart and it'll pull it away. So now what you'll get is you'll get a combination of ClO and an O2 molecule. And this is all when chlorine sees ozone. You're going to get the ClO plus the O2 molecule. Okay. Now what happens is that the chlorofluorocarbon has just broken apart the ozone. Okay. It's destroyed that ozone into diatomic oxygen and a chlorine oxygen bond. Oh goodness, a covalent non-metal chlorine oxygen bond. Now, this disrupts the ozone formation. Okay, it reduces the ozone layers, the O3 layers. All right, so that is essentially how the chlorofluorocarbon breaks apart. The chlorofluorocarbon turns into now this is a halocarbon, right? And that halocarbon can then break apart even more O3 bonds. Okay. All right, guys, we're moving along. We're doing very, very good. Let's move on to C. I'm going to take this piece of paper right there, and we're going to get a new piece of paper. We're going to move on to part C. Okay, for part C, identify the major environmental consequence of the depletion of stratospheric ozone and describe 2 effects on ecosystems and or human health that can result. So what do we really want to answer with this question? We want to look at, identify, figure out one major environmental consequence of the depletion of stratospheric ozone. Basically, what is a bad thing that's going to happen to the environment if O3 molecules are being ripped apart? All right, so now we have this protective layer around the Earth of O3, but what happens if there becomes a hole in it and part of it essentially goes away? Well, what does this O3 do? This stratospheric ozone layer, what does it do? Remember, it is blocking most of the dangerous UV rays. Okay. Well, if there is a hole now present, those rays are now allowed to reach Earth. And those dangerous UV rays specifically, right, there's UVA, B, and C. The UVB are the dangerous ones. Those UVB rays can now reach Earth's surface. Now we all know what happens when you go out into the sunlight, you don't wear your suntan lotion, you get sunburn. Intense sunburns can lead to skin cancer. They can lead to deterioration, eye damage, skin damage, so on and so on. So, with regard to human health, if these UV rays reach, we're talking about skin cancer, we are talking about eye damage, okay? Maybe a combination of the UVB combo of UV radiation with other pollutants. All right, combination of UV radiation with other pollutants, maybe to make more dangerous pollutants, okay, through a chemical reaction, similar to the way that chlorofluorocarbons rip apart the ozone layer. So those are the dangerous parts, the human health aspect of it. Well, what about the ecosystem? Well, if this UV radiation is reaching, so this is human, if the UV is reaching the Earth, well, that could become an issue with regard to food chains. Right, guys? We can have a disruption of the food chain. All right, maybe we can have a disruption to animal breeding. What about with regard to food crops? We think of only ourselves getting burned by the sunlight. Well, plants can also be burned, right? And then this decreases photosynthesis. All right, guys. Okay, and then for our last one, we are going to break apart letter D. So Ozone formed at ground level is a harmful pollutant. Remember, we talked about this. It is formed from the photochemical smog. Describe 2 effects that ground level ozone can have on ecosystems and or on human health. So we want to look for 2 effects that ground level ozone, so ground level ozone can have on human health or the ecosystem. All right, so we know that ground level ozone from our PowerPoint, that could create a respiratory illness. All right, respiratory illness. It could be an eye irritant. Gotta fold this down even harder. An eye irritant. It could wreak havoc on your mucous membranes. Lung scarring. Okay, just think all of this is when you breathe it in, it's going in through your orifices, your eyes, your ears, your nose, your mouth. Okay, it is a pollutant that affects the respiratory system and all parts of that respiratory system. Lung scarring, anything to do with the lungs can lead to bronchitis. It could lead to pneumonia. Now, human health, remember the question said and or ecosystems. So now looking at ecosystems, let's also think about, oh my goodness, I'm sorry guys. We can have crop damage. That crop damage could be due to the pollution, the particulate matter, the UV radiation. Greenhouse gas, huge, huge, huge. Remember, O3 is a greenhouse gas, which means that it increases temperature. Okay, guys? So now it is increasing the temperature of the Earth. That could wreak havoc on ocean environments. Okay, so I hope this has helped you guys a little bit in understanding this. Please, guys, if you have any questions, by all means, please send me an email, send me an email, come onto the Zoom, we could talk about things, we could figure all of this out. So without further ado, I will release you guys from this video. Have a great day and make sure you are keeping up on your work. Turn this light off a little bit. All right, guys, take care. Mr. F saying, have a great day, stay healthy and safe. Bye, everybody.